Hello and welcome back to Math with Mrs. Becker. Today our plan is to review for the Algebra 2 Chapter 3 quiz. Now in 3.1 we solved systems of equations by graphing. And so when we do the first two examples, what we want to do is convert each equation into the form y equals mx plus b. And the reason why we want to convert it into this form is because we are pretty darn comfortable graphing lines in slope-intercept form, okay? So let's go ahead and start off doing that. If I want y by itself here, step one, I could go ahead and subtract that x to the other side. I still would have the negative in front of the y. Remember, a negative is always attached to whatever's behind it. I subtracted the x. It was positive here, so when it moves to this side, it's negative minus 1. Now notice the x term comes before the constant. That's why when I move the x came before my negative 1. To get y by itself, I need to cancel the negative out front. So I divide everything by negative 1. The negative cancels the negative, y is by itself. Negative cancels a negative, I have a positive x. Negative divided by a negative is a positive 1. So there is my first equation. After the x, I have plus 1. That's your starting point. So from 0, I go up 1. The number in front of x, that is your slope. This is an unwritten 1. So I go up 1 over 1, up 1 over 1. I go ahead and graph my line. Okay, because it's a system of equations, what that means is we have more than one equation that we're graphing at a time. So now I go ahead and move to the second equation. Same thing, if I want y by itself, I could take this 4x, move it to the other side. I still have negative 2 in front of the y. The 4x was positive on this side. When I moved it to the other side, now it's a negative 4x. Plus 2, notice the x term comes before the number. Now to get y by itself, I need to divide everything by negative 2. Negative cancels a negative, 2 cancels 2, y is by itself, and that's what our goal was here. Negative divided by a negative is a positive. 4 divided by 2 is 2, that's connected to an x. Positive 2 divided by negative 2 is a negative 1. So there's the equation in slope-intercept form. After the x, I have a minus 1. So from 0, I go down 1. The slope, the number in front of x is 2. That is the same as 2 over 1. So I go up 2 over 1, up 2 over 1. Now we graph them. Okay, here we go. All right, so first we got both equations in the form y equals mx plus b. Then we graphed the system. Now we have to make sure that we're reading through the directions here. Tell what kind of lines you have. You will either have intersecting lines, that means that they cross. Parallel lines, you can see two distinct lines that will never touch, or the same line. Here we ended up with intersecting lines. Okay, so intersecting lines. Let's keep going. Tell how many solutions you have. Remember, your solutions are how many times your lines touch or cross. 0 occurs when they're parallel. 1 occurs when they're intersecting. Infinite occurs if it's the same line. We have intersecting lines, so we have one solution. There is one location, and it is right here. That's the one place where those two lines intersect. If you have one solution, state the ordered pair. So the ordered pair where they cross, I go to the right 2. So the x value is a 2. I go up 1, 2, 3. So my y value is a 3. Okay, so that is one sample. On your quiz, the front page will be 4 questions like this. Get y by itself, graph. Get y by itself, graph. Identify what kind of lines you have. Based off of the kind of lines you have, how many solutions are you going to have? And if it is one solution, can you identify the ordered pair? Okay, let's do this one more time because it is so many points. Notice on the top equation, y is already by itself. After x is a plus 3. So I stay here, plus 3, I go up 1, 2, 3. There is my point. The slope is negative. Okay, so that means I go down 1 over 1, down 1 over 1. That is my line. So I'm going to go ahead and graph it. Now when I look at the second equation, I want y to be all by itself. So I'm going to go ahead and take the 6x and minus it to the other side. I have 2y remaining on this side. The 6x is negative because I moved it to the other side, plus 2. To get y by itself, I need to get rid of the 2, so I'm going to divide everything by 2. 2 cancels a 2, so y is by itself. Negative 6 divided by 2 is negative 3x. 2 divided by 2 is 1. Now here is your second equation. After the x is a plus 1, so I go up 1. Your slope is negative 3, so I go down 1, 2, 3, go to the right 1. Down 1, 2, 3, go to the right 1. So now I'm going to go ahead and connect these. All right, once you have your two lines graphed, now it's time to identify what kind of lines we have. I can see that our lines cross. So we have what are called intersecting lines. They intersect. How many times do they intersect? One time. Intersecting lines will only cross one time. So if you have intersecting lines, that means that there's one solution. If it's one solution, identify the ordered pair. -1, +4, and we're done. Okay? Another thing that we did in 3.1 is if you were given a system and a solution, in order to see if this really is a solution, if the ordered pair 4, 5 is a solution to this system, what that means is I can change all of the x's to 4 and all of the y's to 5. And both equations would end up being true. So let's try this. Instead of an x, I replace it with a 4 minus 6 times y. Y is really a 5. That would have to equal -26. Order of operations, we multiply before we subtract. 4 minus 6 times 5 is 30 equals -26. 4 minus 30 is -26. -26 equals -26. It checks. But the only way you can say that yes, it's true is if this makes both equations true. So now I need to try the second. 2 times x is a 4 plus y is a 5. That would have to equal 13. Order of operations, we multiply before we add. 2 times 4 is 8. 8 plus 5 is 13. 13 equals 13. It checks. If they both work, it's yes. If one of them does not work or neither of them work, it is no. The only way that you can say that it is a solution is if it works in both equations. So this is everything that you need for 3.1. Then 3.2, they said, hey, guess what? Sometimes when you are trying to solve a system by graphing, it's kind of difficult to figure out the exact location where the two lines cross. And so there are alternate methods for solving systems of equations. And actually, they're a little bit more accurate because you're using algebra. So in 3.2, we use what is called substitution and we used elimination. Let's go ahead and practice those. Okay, number 1, let's use elimination. Now, elimination, the goal is to be able to add those two equations together and completely eliminate one of the variables. Well, if I add them the way that they are, 2x plus 3x is 5x, so that would not be eliminated. -3y plus 5y is 2y. So right now I cannot add them the way that they are. Let's say that I want to cancel the y's because one's negative, one's positive. I need to have one positive, one negative, but these have to be the same number. I can turn both 3 and 5 into 15. I would need to multiply every value on the top by 5. 5 times 2x is 10x. 5 times -3y is -15y. 5 times 45 is 225. Now the second equation, I need to multiply every single thing by 3. 3 times 3x is 9x plus 3 times 5y is 15y. 3 times 20 is 60. Now when I add them, notice Negative 15y, positive 15y. They are opposites of one another, so when you add them, you get a 0. 10x plus 9x makes 19x. The y's were eliminated. 225 plus 60 is 285. Now, if I want to solve for x, I just have to go ahead and divide both sides by 19. If I take 285 divided by 19, I get 15. Now, you're not done, though, because what you're doing is the same idea as we did in 3.1. You're saying if you graph these two on a coordinate plane, where's the ordered pair where they cross? Well, right now we know the x. We know that you'd have to travel to the right 15 units, but we don't know if you go up or down, so we have to find y. So what you do here is once you know one value, you go back to one of the original equations. Let's go ahead and I'm going to pick the second one. Okay, it does not matter which one you select. As long as you do the math correct, you would get the same answer. I'm selecting the second equation. So I have 3 instead of x. I'm going to substitute in 15 because x equals 15 plus 5y equals 20. 3 times 15 is 45 plus 5y equals 20. I would minus 45 to both sides, so 5y equals 20 minus 45 is a negative 25. Divide both sides by 5 and y. Negative divided by a positive is a negative. 25 divided by 5 is 5. Once you know x and you know y, you are ready to write your final answer, which should be in the form of an ordered pair. The x value comes first, the y value comes second. So my solution for number 1, we use the elimination method. The solution was 15 and negative 5. Okay, the next one, let's use substitution. Now, the way that you use substitution, you have to have one letter all by itself to do. So if I look, I already have that. Y equals 3x plus 2. So what I can do is substitute that into the second equation. I'd have 2x plus 3, where y is, I'm substituting in its value, equals 17. Every single thing from the second equation stayed except for the y. Y is going to become 3x plus 2 because that's what y is the same as. Now this is just a multi-step equation. I can cancel the parentheses by distributing. 2x plus 3 times 3x is 9x. 3 times 2 is 6 equals 17. I can combine like terms. 2x plus 9x makes 11x. Plus 6 equals 17. If I minus 6 to the other side, 17 minus 6 is 11. So now my equation is 11x equals 11. If I divide both sides by 11, 11 goes into 11 one time. But again, I'm not done because your solution needs to be an ordered pair. I know what x is. In order to find what y is, I can go to this equation that says y equals 3 times x. We know x is really a 1 plus 2. Y equals 3 times 1 is 3. 3 plus 2 is 5. I know x, I know y. I can write my final solution. Make sure when you write your ordered pair that the x value does come before the y. Also in 3.2, we looked at some application problems. If you are comfortable with systems of equations, you can solve a lot of different real-life scenarios. So here's an example. Write a system of equations to solve the following problem and show your work. Tom mixes feed for various animals at the zoo so that the feed has the right amount of protein. Feed X is 18% protein. Feed Y is 10% protein. How much of each feed should Tom mix to get 50 pounds of feed that is 15% protein? Okay, that's a lot of F's there. 15%, 50 pounds, and feed. All right, so what we have here, we have two totally different things. Tom is mixing feed X and feed Y, and he needs a total of 50 pounds. So that gives us our most basic equation. X plus Y equals 50. He's taking feed X and he's adding it to feed Y, and at the end he needs 50 pounds. Okay, so that's the basics. The other idea is behind protein. Remember, when you work with percentages in math, you always want to change them to decimals. So feed X is 18% protein. So that's 0.18X. Plus feed Y is 10% protein. So 0.10Y equals. Now here, you need the total to be 15%. So my total was 50. 50 times 15%, that's the amount of protein that we need. Okay, so to find this again, what I did is I took the total. You need it to be 15% protein. So I'm multiplying the 50 times 0.15. 50 times 0.15, this is 7.5. Okay, so total amount, protein amount. I need 50 pounds total. 7.5 of those pounds need to be protein pounds. Now from here, you can go ahead and do substitution or elimination. Now me, I love elimination. So if I want to cancel the y's, this is positive 0.10y. So if I multiply the top by negative 0.10, I could go ahead and I'd have negative 0.10x. Negative 0.10y equals negative 0.1 times 50 is negative 5. Now the bottom, I am not changing at all because my goal here was to eliminate the y's. And by multiplying the whole top by negative 0.1, I did create opposites here. Negative 0.10y, positive 0.10y. When I add those together, that becomes 0. Negative 0.10x plus 0.18x is positive 0.08x equals negative 5 plus 7.5 is 2.5. So to solve for x, and x represents the number of pounds of feed that you would need if it's 18% protein. Okay, so how many pounds of feed X do we need? 2.5 divided by 0.08. We would need 31.25 pounds of feed X. Now we have to figure out Y. So I have to take X and put it back into one of the originals. Well, to me, this one is definitely the easiest one to deal with. 31.25 plus Y, we need 50 pounds total. So in order to find out how many pounds of feed Y we need, we have to take 31.25 and minus it over to the other side. 50 minus 31.25 is 18.75 pounds. So if you were Tom and you were working at the zoo and you were making this feed, when you measure everything out, you would grab the bag of feed X, measure out 31.25 pounds. Then you would take feed Y, measure out 18.75 pounds, mix it all together, and you would have yourself a 50-pound mixture of food that is 15% protein for the animals. And that was 3.2. Now 3.3 is where we got to graph systems of inequalities. Now this is a skill that we did previously during this class, where you're graphing boundary lines, solid or dotted lines, using a test point and shading. The difference is when they introduced this in 3.3, it's now a system, meaning you have more than one. Your solution is where you end up shading every single time. Let's try a couple. Here, notice Y is by itself. If you only have one variable, your line is going to be vertical or horizontal. Y is by itself, so that means I am cutting the y-axis. The y-axis runs up and down. So to cut the y, I need a horizontal line. My horizontal line is a solid line, and it is going through 4. Now I need to do a test point. Any point not on the line. Well, 0, 0 is not on the line. So if I replace any variable, and in this case, all we have is a y, but if I replace it with a 0, my statement is 0 is less than or equal to 4. Now you ask yourself, okay, is that true or false? Is 0 less than or equal to 4? Well, yeah, so that's true. So what that means is from this line, 0, 0 is in the true side. We always shade the true side. So I have that so far. So what I know is my final solution needs to be somewhere within that region. Now we go ahead and go to the second inequality. It's in y equals mx plus b form. Y is by itself. Whatever's after x, that's where you start. Minus 2, so I go down 2. Notice that the graph is numbered by 2's. The number in front of x is a 1. That is your slope. So I go up 1 over 1, up 1 over 1, up 1 over 1. This would be a dotted line. So I go ahead and I create a dotted line, boundary line. So now what I have to do is see, okay, from the orange line, is this side true or is this side true? So again, we do a test point. 0, 0 is not on the line. If I change y to 0, this side would be 0. My symbol is greater than. 0 minus 2 is negative 2. So true or false? Is 0 larger than negative 2? Yep, that is true. So what I have to do is shade the side from the orange dotted line, shade the side that contains 0, 0. So I would shade right here. Your final answer, now you look and say, all right, where did I end up shading both times? It is this region right here. You're underneath, in my case, it's the brown line, and to this side of the orange line, and you would do something so I could quickly look at the graph and say, okay, where is the solution? The solution is right there. One more, this time we're looking at 3 inequalities. I only have one variable. That means it's going to be a horizontal or a vertical line. This time I'm cutting the x-axis. The x-axis runs side to side. So to cut it, I need a vertical line. It will be a solid line that cuts through the x-axis at 6. So there's the line. Now I do a test point. 0, 0 is not on the line. So this allows me to change any of the variables to 0. 0 is less than or equal to 6. Well, yeah, if 0 is less than 6, that means that I shade from this line, I shade the side that contains 0, 0. So right now, I know that my final answer has to be somewhere within here. It cannot be to the right side of that line. Now I go to the second inequality. Y equals mx plus b form. Whatever's after x is where I start. Notice that it's numbered by 2's. So if I go up 1, I'm halfway between the 0 and the 2. My slope is 1/2, so up 1 over 2, up 1 over 2. This would be a solid line. So I'm going to go ahead, graph the boundary line. That just means it has to go all the way through. Now what I need to do is figure out from this line, is this part true or is this part true? So I do a test point. 0, 0 is not on the line. It was pretty darn close, but it's not there. So we can try 0, 0. If I put in a 0 for y, less than or equal to, 1/2 times 0 is 0. 0 plus 1 is 1. So my statement using 0, 0 is less than or equal to 1. That is true. So that means that I shade the side from the orange line that contains 0, 0. So now I already know that my solution needs to be in this region somewhere, but we're not done yet because we have one more inequality to look at. Let's go ahead and do one more. Y is by itself, so whatever's after x, that's where you start. So I'm starting up 4. My slope is the number in front of x. It's negative 2. So it's down 2 over 1, down 2 over 1. This again would be a filled in or a solid line, because if I was graphing on a number line, it would have been a filled in circle. So my line is solid. Now from the purple line, we need to figure out, okay, am I going this side or this side when I shade? I can try 0, 0. So that allows me to change y to a 0, greater than or equal to, negative 2 times 0 is 0. 0 plus 4 is 4. So my statement from the purple line using 0, 0 says that 0 is bigger than 4. Not so much. So what that tells me is from the purple line, the side that has 0, 0 is the false side. We always shade the true side. So what I need to do is shade this side. So now to find my final answer, I need to look and say, okay, where did I end up shading for me? The brown colored pencil, the orange colored pencil, and the purple? This region right here. We actually formed a triangle, because if you look, I did shade brown because it's to the left side of the brown solid line. It's below the orange line, and it's above the purple line. So your solution is this right here. And these are all the concepts and topics that you will see on the quiz coming up. I hope you guys had a great day. I'll talk to you soon.